my discussion or talk is going to be about the City of Puyallup permeable pavement inventory, our operations and maintenance that we do currently, and lessons learned, I guess. So my name is Paul Marrinan. I'm the senior stormwater engineer with City of Puyallup. I used to be a development review engineer at the city. Before that, in private engineering consulting. My main objective now at the city is NPDES permit compliance with the Phase 2 municipal permit. That's the majority of my time. I also run some stormwater CIPs. I help obtain some grants through ecology so far, which has helped with installation of some of these facilities, and updating our standards to, to help anytime we see issues or concerns or something we can make better with this permeable pavement, then we update our standards to make those changes, I guess, and also help to find and facilitate the operations and maintenance long term. Like I say, I'm not an expert, but I can definitely tell you what we've seen here. Just to give you an idea of City of Puyallup size, just so you can compare it to your city if you're not aware, basically on the 2019 census, we're about 41,000 people, 14 square miles or so, and our elevation at the city is about from 30 feet in the valley to about 520 feet above sea level on the hill. And our maximum road slopes, which would be 5% for permeable pavement, on arterials. I mean, this is just general, I guess. 5% for arterials, 8% for minor arterials, 10% for all others. Those are what we allow. And we are, the stormwater manual we follow is the 2014 Stormwater Management Manual for Western Washington. That's we've adopted. We do not have our own, like Tacoma or Pierce County. That's based on the 2014 manual. Currently, we have 35 permeable pavement roadway installations within the right-of-way. More are currently planned in the design phase. That equals 400,000 or so square feet total installed, 250,000 square feet is pervious concrete, and then about 140,000 is pervious asphalt. And you can see that's like 6.7 lane miles total. You can see from our arterials really where we have the majority of our pavement, which is interesting because everyone's afraid of it, and we just go in whole hog with our arterials here. But we've been lucky, I guess, as far as those projects have gone fairly smoothly, and we've had fairly successful installations as far as we consider them anyway. And so you can see our breakdowns there. Our first installation was in 2012, and since then there's been really a surge of installations since 2017. Majority of the projects that have we put in permeable pavement in the roadways for would be retrofits that we have on our existing roadway, and new development has also installed some of the permeable pavement on like subdivisions, that sort of thing. But like I said, the majority of them have been retrofits. Right. So we also have around 20,000 lineal feet of sidewalk, which is another 100,000 square feet. Majority of it's adjacent to roadways, but we also have some sidewalk link projects that have used permeable pavement and some multi-use paths. Same with this one, they've been constructed as part of development and retrofits, and the majority of them have been installed with retrofit. And this has really been, the sidewalks especially have been clear, that when they're installed in certain areas in the valley, they have helped flooding problems. So this picture here that I have, some of this was an extension, some of it was existing sidewalk, but where it was existing dense concrete, we had pools of water during the wintertime, and now we have no problem with water in these areas. It's all held in the reservoir course or infiltrated. So the design of pavement, what we base ours on would be generally the APWA GSPs. We have some city standard specifications that are in addition to the GSPs, such as our Hydromax additive, which helps the concrete retain its moisture and cure slower. And we found that to be very important additives so that we get the concrete strength that we need. Our subgrade design characteristics have changed over time and depends on what CIP project. Recently, we've used the permeable asphalt treated base below our top final wearing course, whether it's concrete or asphalt. It seems to be easier to lay that down and to work on top of it. It's just been an easier method for us, and it seems to have worked recently. And the reservoir course is generally over-designed for the stormwater needs we've noticed. The depth is based usually on the structural design requirements of the soil. And curb designs, that's another question that we go back and forth on. Do we need a gutter or not? And the answer is really it depends. And you'll see later with our operations and maintenance, what kind of the reason we kind of are going back and forth. But generally, we do install with the belt and suspenders design especially when we're doing retrofits. We install these on streets that already have catch basins, so we keep those catch basins. And if they don't have catch basins, we usually have some sort of system, at least at low points or near existing catch basins, to try to tie in case there's an overflow or in case there's an issue. Because we definitely don't want, I'd rather it overflow into the storm system than to pop out on the surface, which has happened in certain places that it has been designed and installed incorrectly. And this is just an example of our local access cross section, which we have these for local access, commercial, arterials and collectors. They're all fairly similar, but yeah. We do not require permeable pavement installation beyond what the manual states, but it is an option for all roadway applications, that for new development especially. So here is a map of all of our permeable pavement installations in the city. As you can see, the longer, anyway, the red are pervious concrete and the blue are porous asphalt. And the southwest corner, that's 39th by Costco. That's up to 5 lanes of concrete. And then the east side over there is Shaw Road. They're long arterials. Here's there'll be a few pictures here. As you can see, this is Pioneer in front of WSU Extension. We have an 8-foot sidewalk that's concrete, pervious concrete, and then porous asphalt arterial there. And then looking the other way at the intersection here. This intersection will be dense once it's installed. We have the same concerns with the turning movements and that sort of thing that everyone else does for longevity, especially in this intersection. So but beyond that, there are 2 more projects that are slated continuing past the intersection there. And we're having good luck with a lot of these. And this is Shaw Road, newly completed. It has a 12-foot multi-use path, the east side, 5-foot sidewalk that's concrete on the west side. And so with these, the design elements that we've come along with that didn't used to be this way. I guess our first installations were this concrete ring around the manholes. We've had issues with the concrete cracking at the manhole. So we determined this is a better solution than having it directly at the ring cover. Let's see here. This is an installation of pervious asphalt in a cul-de-sac. I took this one specifically so you can see this has been in there since 2017. There's a little bit of scour on the top here, but really it's very minimal. And we do have a lot of traffic through here, not a ton of traffic, just they do have their standard, garbage trucks and that sort of thing coming through here, and it's held up fairly well. So operations and maintenance. So currently what we do to maintain permeable pavements, roadways, is using the Timco 500 regenerative air sweeper. All streets in the city, not just the pervious or permeable pavements, but all the streets in the city get swept once a month. So it's a pretty fair, a lot of sweeping that we do in general, so it works out pretty well. Limitations of the sweeper though for these pervious or porous pavements would be that they have certain paths that clean better than others, where the suction devices are, and then it doesn't clean along the curb. So that is really the biggest reason we are determining or deciding whether to go with traffic curb or standard curb and gutter, to try to figure out how to keep that area clean and how to manage that area. And the other issues we're working with are trees and debris, especially after windstorms, that sort of thing. The entire area gets, the whole city gets debris and trees all over the place, and that really hurts the effectiveness of the pervious pavement. It's time consuming to clean, that sort of thing, especially after those events when you need them to be working. Sidewalks are another issue that we're having. The way we clean them would be pressure washing and clean that with a Vector truck, and that's a slow operation. So our winter operations, just to give you an idea, we cannot plow anything over 5% with the pervious pavement specifically, because we can't treat any of it prior to the snow. So if we use a rubber bladed plow, we don't use any de-icer, ice prevention on the permeable pavements. And the opinions from our operations staff is that it's more difficult to remove snow from the surface since it can't be treated, and it's the first to freeze and last to melt, which is the opposite of what we hear is supposed to happen, I guess. But that's generally where we're at. This is the issue that you guys were talking about before with as new development occurs, we're asked to allow trenching, boring, and potholing for new utilities, for groundwater data, for existing utility depths, or for directional bores. So we have not put these standards in place, but these are ideas that we've had. We're very close to putting them into place. So when we require a panel to be replaced, would be 3 10-inch potholes, maximum allowed prior to the full panel replacement. The city can require the panel replacement if the failure is seen prior to completing work, beyond that 3 10-inch potholes. And then trenching on any pervious concrete roadway requires full panel replacement on any concrete panel that's within the 2-foot minimum cutback from edge of trench limits. And porous asphalt, we would require a T-patch with 2-foot minimum cutback from undisturbed permeable ballast, and it's required to be replaced with a PHMA. But there are instances we're discussing to allow, say, infill lots because they don't have the means to pay for the PHMA replacement, that we would not require them to replace with PHMA if the batch amount would be below 45 tons. But with all of that, we do still follow the manual requirements as the 50% max run on. So if we wouldn't require the PHMA replacement, we'd still make sure, that's another trigger point, I guess. If you're above 50%, then you would definitely be required to replace it with PHMA or permeable concrete. And so even if the dense top course is replaced with dense, then anyway, the reservoir courses still remain. We'd still require it to be placed with the permeable ballast. So difficulties would be raveling, potholing, complaints due to rough surface and joints like we've had on Shaw Road. The transitions, I guess, between dense and permeable pavements. It's slippery. When we first install it, it seems we get complaints that the concrete's slippery. Long-term care and replacement is really the most difficult thing for us, I'd say, the concern we have. Plowing, like I say, that's a concern. Trees and debris are something that we are constantly working with to try to keep clear. Installation difficulties, like we talked about before, they're more variables, and variables seem more sensitive. To keep clean water during construction, check dams are something we've been wrestling with since putting forward design, because it's very hard to install a check dam correctly, and it's definitely something we wrestle with. The conditions of installation have to be perfect, and contractor qualifications is something we also have to track and make sure that we are really on. But it's hard. It's getting easier to find contractors that are qualified, but in the past it's been kind of difficult to find qualifications. And then, like I said before, around structures, we've had issues with settling of asphalt, especially because it doesn't bridge as well, and then cracking at the ring and cover, which we think we figured out a solution for that. And like I said, the joints between existing dents and proposed permeable pavements, or vice versa, has been a bit of a challenge, but we think we figured out a good design for that. And here's one of the examples of this. This was just after that huge wind event we had a couple weeks ago, and under these trees, these cedar trees are always an issue anyway. This is just installed. It's just an example of a difficult location for permeable pavement. And if we had, endless crews to clean this stuff up, it wouldn't be as big of a deal. But it is a lot to do after big wind events. A lot of benefits though for us. It's helps with a lot of flooding problems in the city, in the valley. We have high groundwater, and even when there is high groundwater, especially with sidewalks, since it's not pollution generating, it comes in handy for taking care of some of these issues with high groundwater. Alleys no longer pool with water. We've been replacing with pervious alleys recently. We don't have good robust storm systems through the alley, so when we can replace with pervious pavement, we do. The sidewalks, like I said, are no longer underwater, and sediment transport to waterways, that's, since it goes directly into the ground and we can clean it out of the permeable pavement, we don't get the transport. We do have PMDLs for sediment and DO in Clark Streak, and so when we install these permeable pavements, it's a benefit to that, and we get water into the ground and treated. We do have grants are another one. We are able to get grants from water quality grants from Ecology for these installations, which is another reason to install them as permanent pavement for the city. We can get grants for them. We have been, I guess, we've been very successful with that, which has been a great benefit because it takes at least that initial hit, so we don't necessarily see the higher expense because we get that paid for. It's just the O&M costs and concerns that our crews have been more concerned about. So here's another picture of that sidewalk where it was underwater previously, but now it's completely dry all year round, even when there's high groundwater. So short, medium, long-term maintenance care. As I mentioned before, we have the regenerating air sweeper, which is effective enough, and it does a really good job for us short term, but we need but we need more rejuvenation and more thorough cleaning eventually as we get more and more time with these permeable pavements. And sidewalk cleaning, we use operations are slow and remove workers from other important tasks, but we use the pressure washer and vacuum, the vacuum truck, like I mentioned. Medium term, our plan is to purchase a specific permeable pavement cleaning vehicle. We had Traveris come out and do a demo for us, and it appears they work really well. They're great for rejuvenating and standard cleaning. It's still likely take, say, 4 staff to run because you have the vacuum truck, likely traffic control crew, and usually it's 2 on each of those, and one of those could probably run the Traveris device or the permeable pavement cleaning device, but it still takes a lot of time. Long term, we need to find good solutions for grind and overlay technology, basically how to deal with the pavement once it's degraded past just cleaning issues. And here's a picture from after the Traveris cleaning. You can see on the right hand side there the moss that's grown up on that. And, you can see where they've gone through it. Their 6-foot machine and just cleaned it right out. And previously, it was pretty much not infiltrating, and then after this cleaning, it was infiltrating just fine.